Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we will look at binomial expansions. So we want to be able to expand things like this. So expanding means we're going to start with something that has brackets. We're going to end up with something that doesn't have brackets. So the way that we expand this, the idea is we have to multiply everything in the first bracket by everything in the second bracket. So I have to take x and multiply it by everything in the second bracket, and I have to take -7 and multiply it by everything in the second bracket. So expanding the first bracket, I just go x times x is x squared. Remember, in algebra, if no operation is written, it's always times. And I have to remember that I also have to times x by the second thing in the bracket there, 8. So it's x squared plus 8x. Expanding the second bracket, I go -7 times x, -7 times +8. So I'm now just going to simplify because I have two like terms here. So of course 8x minus 7x is just positive x squared plus x minus 56. I can't simplify that further and I'm done. So another way you can expand brackets like this is using the FOIL method. If you use FOIL, you're essentially doing the same thing. You're multiplying everything in the first bracket by everything in the second bracket. It's just that FOIL is an acronym that helps you keep track of what you're multiplying by what. So if I were to expand these here, F means first, I multiply the things first in each bracket. So that's 2x times 3x, which gives 6x squared. So that's the F. O means I multiply the thing on the outside of each bracket, so that's 2x times +2, which is 4x. I multiply what's inside each bracket, so that'll be -5 times 3x, which is -15x. And finally, L, the lasts, that is what occurs last in each bracket. -5 times +2, which is -10. Once again, I have like terms here, so I need to simplify. 4x subtract 15x is -11x. So now I'm at the point where I can't simplify and I'm done. All right, let's have a look at some shortcuts we can take when we're expanding brackets. So there are two situations we'll go through in which you can use a shortcut. The first is this. It's called the difference of two squares because when you expand it, you have a square minus a square. Of course, minus, subtract, means difference. So this arises when the two terms in each bracket are the same, but one has a plus and one has a minus. So when you're doing such an expansion, you simply square the first, square the second, and stick a minus between them. So here we have the same two terms in each bracket. One is a minus, one is a plus. So to quickly do that, I square the first term, so that's squaring x. I square the second, which is 9, and stick a minus between them. For this one here, I'm going to use the same idea because I have the same two terms in each bracket, but one's a plus, one's a minus. So I simply square the first term, so 2x all squared gives 4x squared. I square the second term, 1, stick a minus between them. So another situation in which you can use a shortcut is when you have a perfect binomial square. So this rule here says when you have a plus b all squared, you square the first term, you square the second term, and what goes in the middle is 2 times first term times second term. Make sure you remember that there is a middle term. Even very intelligent people often forget this. They just square the first and square the second and they forget about the middle term. So here is a perfect binomial square. So to do this quickly, I'm going to square the first. So 4x all squared is 16x squared. I'm going to square the second term. Now whenever you square something, it's positive. And what goes in the middle is 2 times the first term times the second term. So 2 times 4x is 8x times -3 gives me -24x. All right, what about x squared minus 5 all squared? Well, same idea. I have a perfect binomial square. So I'm going to square the first term. So x squared squared is x to the power of 4. I'm going to square the second term. If you square a negative, it's always positive. And then in the middle is 2 times first term times second term. 2 times x squared times -5, which is -10x squared. So of course, with either of these perfect squares or difference of two squares, you can use the FOIL method, you can use the methods on the previous slides, but it would be great if we can use the shortcut to save us time. All right, let's now look at some more challenging expansions. So here we have an expansion that's a little more challenging because I've got my binomial expansion and a term out the front. So just remember the order of operations dictated by BIDMAS. We always do raising to a power. That's what the I is, index in BIDMAS. We do that before multiplication. So to do this, I'm going to leave the negative x alone for now, and I'm going to concentrate on this part. So x minus 3 all squared. I square the first, I square the second, and what goes in the middle is 2 times x times negative 3. So now I can just expand this in the usual way that you've known since year 8. I take negative x and multiply it by x squared. Negative x times negative 6x, that becomes positive 6x squared. And then negative x times 9 is negative 9x. I can't simplify this, so I'm done. So let's look at this here. So this is just going to use the normal rule for binomial expansions that I went through on the first slide. It's just a bit more complicated because we have radicals here. So I'm going to use the FOIL method. So f means first. So I go root x times root x is x. Remember, it's always times here. If no operation is written in algebra, always times. So O, the thing on the outside, will be root x times negative 1 on x. So I'm just going to leave it like this for now. All right, insides. So I'm going to go negative 1 on root x times root x. Well, the root x's there will cancel out, so you'll just be left with minus 1. And finally, the thing that's last in each bracket, negative 1 on root x times negative 1 on x. So I'm going to get a positive because it's a negative times a negative. 1 times 1 is 1. And I'm just going to write root x times x like this. All right, let's just simplify this. I can't simplify x at all, but root x divided by x is actually 1 on root x. What I've done there is divide top and bottom by root x. X divide root x is root x by definition. So then I'm going to leave the minus 1 alone, and I can't really simplify this last term either. So I can just leave my answer like this. There are no like terms. It's simplified, so I'm done. All right, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.